As we discussed in our last video, and in Module 2, a class is a description of how an object should work. An object is a collection of variables that match those specified in the class definition and behave by following the steps in the methods defined in the class definition. The class is declared, usually as a public class, using the reserved keyword class and the same name as the file it is contained within. All variables and methods associated with the class should go inside the braces for this class. Typically, we write all the variables that the class needs at the top of the class definition. They do not need to go in any specific order, but it does help to group variables of like types together to improve readability. Variables can be of any type, primitive or even of a reference type to another class in your project. We're going to talk more about access modifiers in the next video, but a general rule of thumb is to make non-final and non-static members private to ensure information integrity. We're used to thinking about the sequential execution of our code segments. Now we need to keep in mind that any method from any class outside of the constructor can be called at any time. Our class definition should rely on the constructor to set up our object for use. The constructor is called once when our class is instantiated within our program as an object using the new operator. The constructor is almost always public and always has the same name as the class. It can have parameters passed to it, or it can be parameterless, and it never specifies a return type. You can also have multiple constructors if you have different purposes for initializing the variables, but the method signature must differ in terms of number or type of inputs. Methods connected directly to the state of a class are known as accessors and mutators. We'll look at the strategy for implementing accessors and mutators in our next video, but the general idea is that we can use methods to grant permission to client programs to use the information stored by a specific instance of a class. With accessors, usually preceded by the word get, we allow a client to read a value of a given variable. With mutators, usually preceded by the word set, we allow a client to write to the value of a given variable. In both cases, we define how this read or write will behave and can limit the client in ways we couldn't if the variable was made public. Other methods are allowed and can be used as either private, internal methods or public behaviors. For a game, for instance, you might have a hero class that has methods for moving and attacking. If you were to make a texting app, you might have a message class that has a save method, which would write out to a file, or a send method that would make a network connection, encrypt the message, and then check to make sure it got to the intended sender in one piece. Each of those steps could also be their own sub-method, so you could break it down into pieces. Once you've written a class definition that is satisfactory to your purposes, you can start creating instances of that class from your main method. These instances can then interact within the main code segment and even between one another. Each new instance will be pointed to by the variable in which it has been stored when you make your constructor call. When you call methods from that instance, it follows the rules that you've established in the method definition, but uses the values associated with that specific instance. As an example, if I decide to code a Mario game, and then I have an instance variable in my player class for jump height, measuring how high I can jump, the values will be different for the character Luigi than it would be for Mario. My understanding is that Luigi can jump higher. When I perform the jump method that I would write for the player class, even though it would follow the basic steps of moving the character and animating the jump, it would rely on the height that Luigi can jump because that's a value stored in the player class. Okay, the outcomes will be different for either a Mario instance or a Luigi instance of the player class. All public variables can be accessed from an instance of a class by using the reference variable, followed by the dot operator, and then the name of the field. All public methods can be called using the same approach, only following the method name with the parentheses containing any input parameters. This is how the program knows which data to use when executing the steps defined in the method definition associated with that type. If the main method attempts to use a private field or method, the compiler will announce an error at compile time. That's what we're going to look at more in the next video.